Okay, so today's lesson we're going to talk about compound interest. And before we get into any of the word problems, let's just think about what in the world interest is. So in general, interest is like something that you can make when you invest money into a bank account, or it might be something that you have to pay if you take out a loan. So for example, when you take out student loans, you have to pay so much interest based on whatever amount you take out. Okay, so that just gives us a basis to start. So the first thing we want to talk about is comparing simple and compound interest. So simple interest would say that if you're investing $100 and your interest rate is, we'll say 3%, that means every single year you're going to get $3 back. And it's not going to change the amount that you have invested. It's just going to be how much you get back every year. So like year one, you have $100 and you get $3 out. Year two, you have $100, you get $3 out. Year three, right? This is assuming that you don't ever do anything. They just give you $3 every single year. That's simple. Compound interest should kind of remind you of a geometric sequence. So compound interest is going to say you start with $100 and you invest at 3%, so they're going to give you $3 back. But instead of giving you the $3, they're going to reinvest it for you. So now you have $103. Oh, I messed that up. In year two, and now we're going to do that one at 10%, which is this year is going to give you $3.09. Oh, 9. All right, so then the next year when you go to invest, now you have $106.09. And when we invest that at 3%, now we're going to get $3.18 back, and so on and so forth. So you can see compounding interest works in your favor, because at least if you're investing, because you're going to be getting more back each time, because they're going to be putting it back into your account for you. So because of that, we have some formulas that we want to use. Now, last week we did y was a 1 plus r to the t, or n, and I'll actually use n. And remember, just some things to remember. A was the starting point. R was your rate. Remember, you have to write percent as a decimal. And then n was the number of times that happened. So the formula that we're going to use today is really very much the same, except now it's going to be y equals, they use P for principal. That's a word that you need to know just in general life. The beginning of any loan or any bank amount is called the principal. All right, and then R is going to be your rate, so it's still 1 plus R, and now T is going to be, that's going to stand for time, how long you're doing this process over and over and over again. So still the same values, just notice some of the letters are going to look a little bit different. So let's look at some examples. Okay, so here's our first problem. In your notes, you probably need to take bullet points of the important information. So I would write down, they invest $200. The account earns 6.25%, and it is important that you know that that is annual interest. We're going to talk about that here in just a minute. And then we want to know what's going to be the value, or when will the value reach $5,000. So instead of A, remember we have P now for principal, so P, R, and T. So our principal amount is 200, that's what we're starting with. Our rate, 6.25, remember we got to move the decimal place 2 times, so our rate is going to be 0.0625, and then time is unknown. So we're going to write our equation from this, y equals 200 1 plus 0.0625 to the t power. And now we're going to use our calculator. And in our calculator, we're looking for where does it hit 5,000? And it looks to me like that's going to be somewhere in between 53 and 54 years. So the first time that you're going to be at least 5,000. So the when will be 54 after 54 years. And you may say, well, holy cow, that's a really long time. But think about it. You were you put it in the bank and magically you turned $200 into $5,000 for doing nothing. All you had to do was wait, but you didn't actually have to do anything. It just increased its own value. All right, let's look at some others. Okay, so I told you on the last one to pay attention to the word annually. That's because it's just going to happen one time a year. There are other ways to compound interest, and those are ways that are going to be compounded more than once a year. So I would maybe label this section of your notes compounded more than once a year. So you have a few options. You could have semi-annually, which is going to mean that it's going to happen 2 times a year. Think about like the semifinals, right? Or something like that. That means 2 times a year, 2 times per year. And then you could have quarterly, and think how many quarters are in $1, right? That's going to be 4 times per year. Or you could have monthly, which would be 12 times, right? Or we could have weekly, which is going to be 52, or you could have daily, right? Like this could keep going. You can say however many times you want to compound. And then we're going to talk about one more after this. So any of these are going to be a slightly different formula. So it's going to look first part of it's very much the same. It's still P for principal. And now we're going to do 1 plus. This time my rate is happening a number of times. So we have to divide by however many times the rate is happening, and that's going to be n. So all of these values that I just gave you, those are all n values. So if it said quarterly, then n in your equation here would be 4. If it said daily, n would be 365. And then we still have t out here on the end, but also you have to think, how many times is it going to be happening? Well, it's t, that's the number of years, times n, which is the number of times per year. So, for example, if this was happening for 5 years, but it was monthly, then that would be 5 times 12 as your exponent, because you have to have 12 months for a total of 5 years. So anything that's compounded more than once a year is going to have this formula as the equation that you use. Okay, so we're going to go back to our original problem, except this time notice that we're going to be compounding weekly. All right, so all of our values are still the same. 200 is still my p-value. All right, there's my rate. This time, though, we want to do weekly, so let's go ahead and write that equation out. We're going to have y equals, remember weekly means that n is going to be 52 because there are 52 weeks in a year. All right, so y equals 200, 1 plus 0.0625, except this time, remember, because it's happening over and over again, we have to divide by 52. And we're going to raise that to the 52 times t power. All right, look back at the equation that I had on the previous slide. Make sure that you understand why I am including the 52s here. That's just your n value, and I'm just plugging it in. All right, so now we're going to use our calculator. Okay, so this time when we look at 5,000, it's going to be happening between 51 and 52 years. So we'll say that that's somewhere around 52 years is how long that will take. So notice this time when you're compounding more, when you're using your interest rate more frequently, it takes less time. Remember, if you only did it once a year, it took 54 years. So let's think about what if you did the same investment except you compounded daily. All right, so if it's daily, n is going to be 365. So my equation is going to look exactly the same except for my n value. So it's still going to be 200, 1 plus 0.0625. This time I'm going to divide by 365 because it's daily. That's how many times it's happening. And then we're going to have 365 t. And let me use our calculator for that. And notice this time, 5,000 is still happening between 51 and 52 years, but the value is slightly higher at each of those points. So this one is still 52 years, but the big thing that I want you to notice, so you should probably put a star in your notes, the more frequently you compound, the more quickly you're going to earn money. So if you have the option to compound daily versus once a year, then you want to do that because that's going to work in your favor. Okay, there is one more type of compounding interest, and that's when you compound continuously. So the last time I said like daily was the most you could do, but now it's like you're compounding, it's like they're counting every single second. They're not like pausing and waiting a certain amount of time before they start counting again. They're going to compound every single second and give you more and more money. So that one's going to have a slightly different equation, and it's going to be y equals, we're still going to start with our p, and this time we're going to have a number called e to the RT power. All right, now P, R, and T still mean what you think they do. All right, they still mean principal, rate, so that's your percentage, and time, how long the investment is going to happen. This time right here is always going to be in years. The E, though, is something that you have never seen before. And E right here is an actual number. It's not a variable. Think about, like, pi is 3.14 blah, 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 right? That's a number. E is another number in math. It's just a constant. And you don't necessarily have to have this memorized, but E has a value of 2.718, and it is on your calculator right here. All right, so notice that I know that's definitely going to be difficult for you to see, but it is on your calculator above your division button. We'll look at that specifically in class tomorrow. All right, so let's think about the same example that we've been doing and see if compounding continuously makes it any sooner than we've had before. So we said, remember, our principal was still going to be $200. Our rate was 0.0625. Remember, we had changed that already from a percentage. Our T is going to be unknown. So this time when we write our equation, we're going to have y equals 200, still start there, but now there's no parentheses. This is just the number E to the RT, so that's 0.0625T. All right, we're still going to use our calculator to figure out when we can hit our 5,000 amount. All right, and we have got, right here, we're still in between 51 and 52 years, but just barely we're beating out even the daily rate. This is going to be continuously is the most that you could ever compound. Like, how can you compound more frequently than doing it every single moment? That's not even possible. So here we're still going to be at 52 years. All right. So the things that you need from today, you need to know the difference between when you're compounding. You need to know that the more frequently you compound, the more money you're going to make. And then you do need to remember these formulas that I've given you. So maybe go back in your notes and put a big box around every formula, because those are the 3 that you're going to need for class tomorrow.